My name is Associate Professor Sam John from the Department of Biomedical Engineering. The subject I'm talking about is bioinstrumentation. Bioinstrumentation is a master's level subject. It's a core subject within the biomedical engineering course, but it's not a prerequisite for other subjects. So in bioinstrumentation, we look at the very fundamentals of electronics, and we look at the fundamentals of how electronics can interact with the human body and how it's used in the hospitals. And then we put all of that together to make safe and efficacious bioinstruments. In bioinstrumentation, students learn how to design, build, and evaluate bioinstruments so that it meets regulatory requirements. So at the end of the semester, students would have learned how to design these instruments, how to test them, and use them as a medical device on the human body.
We actually did a site visit to a robotic surgery training center, and the project that we ended up doing in the subject is based on a need in the training center, so that was quite cool.
Bioinstrumentation is a very practical subject. So students come in and they learn how to design and build their devices and how to make these devices work for the patients. Students also interact a lot in class. So we don't have lectures, we have discussion groups. And in these discussion groups, we work through the design process and how to get to an end product. And finally, in bioinstrumentation, we will also assess the progress of the project throughout the semester and not the end product.
It's one of, I think, 3 subjects that you really get to dig in and do some practical work. And I work on a project that runs through the entire semester, which is great. And if you're into medical devices like a lot of us are, you get to do something that's medical field related, which I think really pulls you in and is a motivation for understanding a lot of interesting concepts.
Biomedical engineering is a really exciting area, and bioinstrumentation is at the forefront of bringing students into the bionic age.
I'd recommend it to students who are quite hands-on, enjoy making things, enjoy making circuits.
You can be really excited about the subject, about the opportunity to really direct what you'll be doing, about the opportunity to build something real. And it is really rewarding to start something from beginning to end and see it come together and hold something in your hands that you made and does something that you wanted it to do.
The ideal student is someone who is curious about the process, someone who is willing to take risks, someone who is open to failure, and someone who is willing to collaborate with their peers.